Okay, so today I'm doing chapter 3 and just going over that. So for chapter 3, it's all about molecules and compounds. And we know that there are three types of chemical formulas: the empirical, molecular, and structural. So structural is a sketch or diagram of the structure of a given atom. So if we have like hydrogen peroxide, we might do HOOH, and that just gives us like a sketch of what the atom would look like. And then the molecular formula is the exact number of atoms in a compound, and the empirical formula is the simplest whole number ratio of a compound. So basically, an empirical formula example would be like CH2O, which is empirical formula because it's the simplest whole number ratio that we have. And we know that ionic compounds are nonmetals and metals, consist of nonmetals and metals that transfer between one atom to the other. And usually the metal brings an electron over to the nonmetal. So the metal is the cation and the nonmetal is the anion in this situation. And we know that when we're naming metals with a single charge, you just put the name of the metal and then the nonmetal and you end with I. So if you have CaI2, you put calcium iodide, or And then we also know that, N2O would be like sodium oxide. So we just keep putting the I to the end. And then when we have two transition metals with different charges, we put the metal first, then we put the number in Roman numerals, and then you put the non-metal, and then you put I. And usually the transition metals would be copper, which is Cu, iron, which is Fe, tin, which is Sn, and lead, which is Pb. So if you have FeCl3, that'll be iron, Roman numeral 3, and then chloride. And then we also have oxyanions and polyatomic anions. And that's basically the one with the more oxygen atoms will have 8, and the one with fewer will have 8. So NO3 minus is nitrates, and NO2 minus is nitrite. And PO43 is phosphate. And we also know that NH4 plus is ammonium, and SO4 2 minus is sulfate, SO3 2 minus is sulfite. And then we also have covalent bonds, which is two nonmetals that bond together. So that can be hydrogen, oxygen, sulfur, nitrogen, those type of things. And that's when we start to use prefixes. So the mono, di, tri, penta, hexa, stuff like that. So when we're doing that, we name the prefix first, then the first element, then the prefix again, then the second element followed by I. So an example of this would be PCl5, which is the phosphorus pentachloride, and N2O4 would be dinitrogen tetraoxide. And then also we did dot sketches, which is when you have different, like a broken sketch of an atom, and then you connect the dots to see which electrons are bonded together in pairs and which ones are left alone. So lone pairs and bonded pairs. So we also talked about the mass of percent. The mass of percent is the molar mass divided by the mass of the mass of the compound times 100. So if you're trying to find the percent of mass of oxygen in an element, you would put the molar mass of oxygen, which would be 16, and divide that by the whole mass of like whatever element that oxygen has, and times that by 100, and that will give you your mass percent. And then we also talk about grams, moles, so grams to moles and moles to molecules, and how you can go vice versa. So if you're trying to go to molecules to moles, you would divide by 6.022 times 10 to the 23rd. If you're trying to go from moles to grams, you would multiply by the molar mass to grams. And we also talked about the empirical formula, which is if you're given a percentage, you would assume that that's 100 grams. So if you have 69.9%, you would just put that as 69.9 grams. And you divide that by whatever the mass is, and so that you can put that conversion into moles. And you do that for both elements, and you would find the ratio from that. And it's the simplest whole number ratio between two given atoms as well. And then we also talked about the molecular formula, which is the empirical formula times N. And N is the molar mass divided by the mass of the formula. And the molecular formula would usually be a whole number. So molecular formula can be 6, and then we would just multiply 6 by each and every single thing in the element.